Okay, let's go.
Let's start.
Cool. All right, welcome. Thank you all for being here. So this talk is about developing, deploying, and scaling in the cloud with Play. Who here has used Play before? Awesome. Great. Okay. So for those of you that have used it, this is going to be a nice introduction to Play 2 and what's new in Play 2, and also to deploying Play applications in the cloud and using GitHub for collaboration. And then for those of you that are new to Play, we're going to talk about the differences between Play 1 and Play 2, and really just do a lot of live coding today so you guys can see what the development experience is really like. And we can make this as interactive as possible. Feel free at any time to stop us and ask questions and interject comments. And we've got Guillaume here and Sadiq here, sorry, so they can answer the really in-depth questions because they created this thing. So and Nikolai is also a contributor. So okay,
yeah, let's start. So yeah, what do we do today? So first we'll explain what is Play. I think most of the people knows what is Play, but we'll make a nice introduction for the people who don't. After, we'll be playing a bit with Git and explaining a bit what is Git for people who don't know Git. Yep. And we'll focus on GitHub, actually. And we'll see Heroku in action.
Yep, so you'll see Heroku.
And we decided that it would be really nice to actually have a proper CFP application. Because I don't know if you try to submit talks here, but...
So that's going to be our goal today, is to build a new call for papers application for DevOps. So we're not coming back next year unless they have a better application to use. So.
And we won't have a break because we started too late.
We'll still have a break.
Oh, yeah?
No break for you.
After the break, we'll try to improve our application. We'll build nice RESTful services to consume it on the client, and we'll try to see some HTML5. And after, Guillaume will join us and will actually demonstrate testing. We still don't know what is testing because everything is type safe anyway. So
that's right. We don't really need testing, but we'll do it anyways.
And after, we'll do some advanced stuff with showing you Akka, Comet, etc.
Great. So I guess we should say who we are.
Yeah, true. So who are you?
So I'm James Ward. I'm a developer evangelist at Heroku, and I just joined Heroku about 9 months ago. But since then, I've been focusing a lot on Play Framework, and I live in Colorado in the States, and I've been going around the United States telling people about Play Framework and how great it is and how to deploy it on the cloud. And so it's been fun to really get involved with Play Framework, and it's such a delightful web framework to use. So that's great.
So I'm not Guillaume Bort.
No.
He was supposed to be here, but he doesn't want to talk anymore. He's bored. He will join us later on. I'm Nicolas Leroux, actually. As you can see, I'm living in Holland. That explains my really strong Dutch accent. No, I do live in Holland, seriously, in Rotterdam. But of course, I'm French. I'm a technical director of Lunatech Labs with a small company. And I happen to be also a contributor to Play Framework.
Awesome. And I was going to mention, I don't know if anybody wants to try to follow along with us as we work, but I've got 4 USB keys. These aren't GIFs, but I will pass them around. So if you want to load Play 2 and the Heroku client on your machines while we're talking and try to follow along, you can do that. So I'm just going to put these here. We'll start 2 here. The JFrog one, this one it's kind of complicated to use. It's a card. It's not as complicated as Artifactory, but it's just a simple little USB key here in the card. So Artifactory is much easier to use than the USB key. So we'll start 2 going this direction. Feel free to just find somebody. And this one's a bottle opener, so if anybody has any beer that they need to open. But I want this back. This is my favorite USB key. Because
I think after 3 hours you will need a beer, actually. Let's go to. So first we'll explain what is Play. So first, Play 1. What is Play 2 is not Play 1. That's really important. Play is designed to be highly scalable, web-friendly, and lightweight.
So I like the web-friendly part. Peter Hilton, one of the other Lunatech guys, he did a presentation at JFocus, and he said, whenever your web framework fights the web, your web framework loses. It's not the web that loses, right? And so Play Framework is really trying to be URL-friendly, web-friendly. We'll see that in a lot of ways, and we'll point that out. But I think that's really important. A lot of Java web frameworks have tried to fight the web and what the web was and how the web worked, and Play is not doing that. They're really working with how the web was architected to work.
Yeah, so Play is a web framework and emphasis on the web. So it's not, it's really designed to make some web application. The new feature of Play 2 is also really designed to scale up to millions of concurrent users at the same time. There's a
good example of this scalability in the Zenexity booth. They have this real-time game that's built on HTML5 and on Play 2. Really showcases how Play 2 really scales up to these real-time, really intense applications. So go check that out in the Zenexity booth.
So Play is also stateless by nature, which allows this scalability. So it means that no state is on the state is not on server as much as possible. So actually there is no state on server. Yeah. We'll try to see that a bit more in detail. It's also using the latest non-blocking I/O server like Netty. It's using also a new model of to consume streams and redispatching streams with the iterative model. And type safety is one of the major new features of Play 2. It's actually not type safe, but type safety. Play 2 is also used on the type safe stack. That's why I think I mix up a bit.
I think this is a really important differentiator between Play 2 and like Grails. I haven't used Grails a whole lot, so I don't know a whole lot about it. But people say, "Hey, Play looks a lot like Grails," and from my perspective, that may be true. But the thing that really makes it different is the type safety that you get as you're writing code. So your controllers, even your routes, really everything is type safe. So for me, that's huge. I like to write in statically typed languages and have everything type checked by the compiler, so that I don't have to write a million tests. So that's a huge feature for me.
Yeah, and everything is really checked. So even your JavaScript, we'll see, is checked for type safety. So what is Play also? Yeah, one important feature is you don't need a deployment step. Everything is automatically recompiled. When you hit your browser refresh button, you see the result immediately. It has a URL-friendly routing file, so you can declare your URL and say this map to this controller or this thing, which is kind of hard to do in the classical servlet using servlet API. Play 2 has also Java and Scala native support, and you can extend it pretty much with anything you want, actually. Yep. And of course...
And the best part of all, you can deploy your Play apps to Heroku. So we'll share that later.
So yeah.
So if you're familiar with Play 1, we wanted to talk about some of the differences between Play 1 and Play 2. So the first one that we mentioned a lot is that it's type safe everywhere. As Nikolai said, it's not just your code that you write, but your routes, even the JavaScript or CoffeeScript that you write, all that stuff can be type checked. So that makes the coding experience very nice. You'll see in a little bit the error messages that you get if you make a mistake. Then the core of Play 2 has been rewritten in Scala. So this was a major change from Play 1 to Play 2. And this makes the whole Play stack really well suited for doing this high performance stuff, because now it's based on Scala. It uses a lot of async handling and the iterative model. So a lot of that is powered by Scala internally.
Who is actually using Play 2 now?
Anyone using Play 2?
Okay, quite a lot still.
A couple people.
Okay. So most people are familiar with Play 1, I guess. So this is interesting still. Okay. So yeah, a big difference also is Play 2 is on the official type safe, the Scala company stack. So it's professional open source. So this means that you can get support, professional trainings, etc. On Play
We
2,
missed them. No more magic. That's
that's true. Sorry.
So Play 1 had a lot of magic behind the scenes. It was doing all these magical, wonderful things for you. But the challenge with that is that when the magic didn't work for some reason, it could be hard to figure out why the magic stopped working. It's like when Harry Potter's wand stopped working. It's like, why is my wand working? And it is kind of hard to dig into that. So Play 2, they really tried to take a lot of that magic stuff that was happening through bytecode modification and stuff and take that out so that it's more understandable how things are actually working and more debuggable.
By magic, we mean bytecode enhancement and continuation, essentially. So yeah, an important switch also is Play 1 was using Hibernate and GPA, and Play 2 by default is using ebean, with known as the stateless ORM.
So that's with Java. If you're using Java and Play 2, then ebean is the default persistence mechanism. You can, of course, swap that out with other persistence mechanisms. It's very easy to drop in things like MongoDB, but the default RDBMS persistence engine is now ebean.
And it's a norm for Scala. How many people are doing Scala, by the way?
Scala? Okay.
Okay, not so much. Because we were hesitating, shall we do the application in Scala or Java, and we chose Java this morning. But an important another point is Play 2 is even more modular, which means that your template engine, you can plug another one or whatever you want. You can choose your if you want to persist with ebean or GPA or Hibernate or whatever you want. This is now all easy and possible with Play.
So it's easy to modify all the different pieces of how things are happening in Play 2. If you don't like that A-norm is the default persistence engine, then switch out for Squirrel or whatever you want to do persistence with.
And you can even switch language. So you can you decide that you want to use Kotlin. I think it will be possible really soon to use Kotlin. Or
Is anybody here trying Kotlin? Kotlin? Anybody here heard of Kotlin? Okay, a couple of people. Kotlin's a new language by the JetBeans guys. So they have announced that their web framework is also going to be Play 2 for the Kotlin web framework.
And what about Ceylon? People using Ceylon?
Ceylon? Gavin King's new phone thing.
No?
So.
Okay. Well, it's just we're doing some statistic at the same time. So.
Yeah.
So Play 2 also, the core is using mainly asynchronous features and Akka. We will not go into detail really much on this. We'll let Guillaume explain this to you when we are on advanced feature. Template by default in Play 1 was Groovy, and now it's Scala for Java and for Scala.
That's of course changeable, but the default now is to write your templates, your server-side templates in Scala.
But the idea is you don't fully notice that you write Scala. So there is a lot of helpers, etc. So you will see when we will develop, you will not really notice anything. This is an asset compiler for JavaScript, CoffeeScript, and less. So this means that you can write your CoffeeScript and you hit refresh on your browser, and then poof, you have your JavaScript already, and you don't need to do much. It's quite nice as well.
So this is one of my favorite new features of Play 2 is the asset compiler. Now most of our applications that we're building are using server side for services, mostly stateless services, and then using the client side, the JavaScript engine on the client, and CSS and CSS3 to do the UI. And so being able to have an end-to-end development tool that can deal with both sides of that problem, both sides of the development, is really productive for me. So you just put in your JavaScript or your CoffeeScript, and it'll compile it, it'll minify it if you want. All that stuff just happens automatically. So I really like this new feature in Play 2.
In Play 2, there is no more Python dependencies, so it's using SBT. Who knows SBT?
Scala build tool, a couple people.
It was once called simple build tool, I think. But anyway, from Ivy, we went to SBT also.
Which uses Ivy underneath the covers, but now we're not at least manually managing our dependency management through Play Framework. It's all done through SBT.
The compilation, everything is managed by SBT. And you can have also in Play 1, it was released, everything was hard-coded, a bit like Rails, like the Java file models, your model files had to be in a package models, etc. This is no more true in Play 2. You can customize everything.
So the configuration system in Play 1 was kind of a custom written configuration system. And now part of the TypeSafe stack, TypeSafe, the company behind Scala and Akka, it has a configuration library that's now standard across all of the parts of the TypeSafe stack. So now Play 2 uses that configuration system to do config. It's really powerful. It was written by Havoc Pennington, who's a TypeSafe guy. And Havoc is one of my personal heroes. He wrote the Metacity window manager on Linux and is now doing server-side stuff. So Havoc's brilliant, and it's great to have him building this kind of libraries that we can use in Play 2.
And I think it's about time to, because Play 2 is also a certain philosophy. We try to explain you with, it's a web framework for web developers, and we'll try to explain the Play philosophy. First, Play is made in France.
Yay!
No?
Right? Is that a good thing? Okay.
So, I mean, it's now really election time, so it's like everyone is like, wow, we have to do things in France to consume French. Here it is. Please consume French. Anyway, so what is France famous for? Love. Yeah.
Love.
So it's exactly
That's
what
good, because
what
Play gives developers love. I feel loved by Play.
Yeah.
It loves me.
So you're not alone anymore. You have your little Play. Yeah.
Yeah.
Food. Yeah, food.
Food.
Yeah, and Play gives you food for stuff because it breaks all the Java convention and establishment. No servlet API, nothing. So you're like, oh, food, yeah. And France is famous for wine.
Wine.
So we couldn't find anything except that now you will have time to drink it and enjoy it.
That's good. We can drink more wine.
Yeah.
Thanks, Play.
Thank you. And it's also one of the main philosophy is simplicity. And this is actually quite hard to achieve because being simple is really hard to and satisfy everyone is really hard to achieve. But this is really what Play 1 focus on, and Play 2 even more. It's time for a demo.
It's time to see some code, right?
Yeah.
You guys ready for some code? Any questions before we go on?
Yeah.
Comments, questions? Okay, let's see some code.
So what do we do? Today we coding a new.
So we're going to start totally from scratch here. We're going to create a brand new application to be our call for papers application. So we've downloaded Play 2 and we've installed it locally, which just means unzipping it, and then we've put the Play 2 executable in our path so that we can call it. Yeah, question in back. Oh, font. Can we increase the font in there? Thank you. Sorry about that.
We do that.
So,
Plus, control what?
Control Shift plus.
Shift plus. No. No.
All right, we'll get the font. There we go. We'll get the Mac expert up here. This is Guillaume. Hey, welcome, Guillaume.
Hey, welcome, Guillaume.
All right. Is that better?
Thank you very much.
Hey. He's not just the Play expert.
Yeah, he's also a Mac expert. TextMate expert. He doesn't want to come because we'll use Eclipse. And it's like TextMate. No, I'm not coming if it's Eclipse.
Okay, so we're going to create a new app.
Yeah,
so we've installed Play. We've got the Play command. We've aliased it as Play 2 just so that we can differentiate on Nikolai's computer between Play 1 and Play 2. But usually it's just Play. So you call the Play command and say new, and then give it the name of the application. So we're going to say new and then give it a name. So CFP.
Yeah.
So now it's verifying. Are you sure you want the name of your application to be CFP? Yep, we do.
What do we want to do? We want a simple Java application.
So we're going to use Java today. If you want to see some Scala stuff, maybe at the end we'll have time to show you some Play apps with Scala. But for now, we're just going to do Java since I think that's what most people here are using.
And that's it.
Okay, so our application is created.
Yeah. So shall we just see? So we created the directory, and here is our application, the start.
So you notice that this is not the standard structure of a Java web application. There's no source main web app. It's its own structure. So in here is the source code for our application, the routes, static assets. We put our tests in here. So we'll show you the structure in a little bit. But this is the basic Play application structure.
Okay, so now I guess we want to load it in Eclipse, so you can see something.
So there's built-in support for Eclipse and IntelliJ so that we can generate out the project files for the IDEs. You, of course, don't have to use an IDE. You can do it all with TextMate or whatever text editor you want. VI is my personal favorite. Totally up to you, but just so that we can show you the structure and things easier, we're going to use Eclipse.
Is that not working?
So it's going to take our project now. It's going to build this project and then generate the Eclipse files, and then we'll open it up in Eclipse. You'll see that we practiced it. We practiced earlier, so we've got an example one here. But now we can just go and import this project. So it's created the project files. We can just import an existing project, and then we'll have everything up here in Eclipse. Okay. So there we go.
Wait. There is a little bug right now, so
there's a little bug in how Eclipse generates, where it generates its files, and so we're going to just fix that real quick. We've got to go into the build path. We're going to change this to Eclipse-classes, and then do the other one for the test. Actually, the test one probably doesn't matter. I'm not going to be showing you tests.
Yeah, but we'll do it.
So this will be fixed in 2.01. Okay, cool. Okay, so here's our project in Eclipse. You'll see the same directory structure that we saw before. And let's start up the server to get it up and running.
So we just learned today that there is a little trick if we do that.
So we run play2 or play run. You can run twiddle run, which will monitor files for changes and automatically recompile them. Or you can just do play run, and play run will then, when you reload in your browser, it will then do the refresh. So we're going to do twiddle run, and then just go to localhost 9000. That's the default port for Play. So this is actually using underneath the covers the Netty server. So Play has its own HTTP handling library, its own HTTP engine inside of it. This is a bit different than the typical approach where you create WAR files and deploy those WAR files into a container. That container has the HTTP handling built into it. So in this case, we've gone containerless. We are using Play's HTTP engine. If you really want to create WAR files and deploy them into containers, you can do that. It's, from my perspective, that's not the recommended approach, just because Netty works really well. It's really lightweight, starts really fast when you just do it all in the same library. So this is kind of the recommended approach, but it's up to you how you decide to do it.
And what is really interesting, and because of this Netty is embedded in your application, what you can do is package your complete application with the server. So with playlist, you just package everything, and you have everything ready, and you have one file, and that's it. Yeah. So that's really interesting. Now I think it's time to show you a bit what is what.
Yeah, so we just made a HTTP request to the Play server, and so somehow this request got mapped to our Java code to make this request, to determine what actually gets returned in the response. So to start with where this happens, let's check out the conf routes file. So this is where we define our routes for, larger?
Yeah, larger, okay.
Larger in font size or larger?
Font size. Yes.
So this routes file is the place where we define a mapping between the HTTP verbs, the HTTP paths, and the actual code that we want to execute to handle the requests.
Is that good enough? Yeah.
Is that good? Okay,
yeah.
Awesome. So what you're seeing here is that for a request that has the HTTP verb of get and the path of slash, we're going to call a controller that's in controllers.application.index, the index method on the application object.
This is what usually it's your the similarity is a web.xml. In web.xml, what you do is you define a certain mapping to servlet, except that you don't have so much freedom with whatever you want to do. It's either you match, you list them one by one, or either you match everything and you dispatch to a servlet dispatcher who after does something. Anyway, so now I think it's time for a bit more interaction.
Let's pull up the application controller.
Yeah.
So this is the Java controller class that's now getting past this request. So you'll see that there's a public static index method that returns a result. And the reason why it's static is actually pretty important. The HTTP protocol is a stateless protocol. So you make a request, you get a response. And between requests, there is no state. And so Play really wants you to think about HTTP in terms of this being a stateless protocol. So the fact that this is static means that you can't have state between requests. So that's a really important part of Play, is we're not trying to hide the HTTP protocol from you. We want you to understand that in the HTTP protocol, it is a stateless protocol. You get a request, you return a response.
Okay, so let's see if we change that, I guess, first.
So let's make a quick change here to this controller. So we're just going to change the string that's getting passed to the template. We'll cover templates in just a second.
We'll just an area of you.
So just refresh in the browser, and now we're seeing that change instantly. So it's automatically recompiled the Java class for us. There's none of this like recompile, rebuild war file, redeploy war file, possibly restart Tomcat. Your development cycles in Play are much shorter because all you have to do is go to your browser, hit refresh, and you're going to see your changes. Whether those are changes in Java code, templates, config, JavaScript, your configuration, all that stuff is just going to be automatically recompiled.
So now let's try to input some name. So
we want to take a name as a parameter to this function, and so we can actually get this name now from the actual request URL.
Who can tell me what will happen? It's an interactive quiz where you can win a sticker.
Ooh, we do have some stickers somewhere.
We do. No one? Okay, let's try it. Oh.
So we got a compiler. So this is where Play really helps you with your development, is it's actually going to tell you exactly what's wrong with what we just did.
And what you say is like we didn't specify a parameter name.
So you told me that you needed a parameter, but where is it?
So let's see.
So now let's actually just use a get request parameter and pass that in.
No, still not, huh?
Thank you. Compilation error. Because it's all type safe.
Yeah, so what we'll do here is we'll tell him, okay.
So now we tell it what parameter we want to pass into this. So now, there we go. So we've just taken that request parameter, and Play is automatically mapped, figured out based on the name of the parameter, how to map that into the method call that it made to the index method.
Yeah, so now we'll have a look at the template.
So before we do that, let's do one other quick change.
Yeah.
Let's do a RESTful style URL thing. Let's say we want to take that name and actually get it from, instead of a request parameter, but actually get it from part of the URL. So we do this notation to say :name in the spot in the URL where we want to pull that out. And now instead of specifying it as a request parameter, we can specify it as actually part of the URL. And again, Play knows how to map that parameter into that method call that it's making.
Yeah. So let's have a look at now. So we'll show you what's.
So real quick, flip back to application.java.
Yep.
So we'll see here in application.java, we're returning an OK, meaning a status code 200. Everything's OK. So we're actually, again, not hiding the HTTP protocol from you. You actually are telling the browser, telling the HTTP response what its return type is. And so it's a 200. It's OK. And then we're saying, what do we actually want to be as the body of that response? And we're actually using a template. So index.render is calling a method on a compiled template to actually get this template in HTML and be able to then return that as the body of the response. So let's take a look at where index.render comes from.
So this is actually this template. This is a template composed with a main template, and the main is defined here. So it's really simple. What is interesting here is that you pass a parameter to the template. So you say here, I expect a message.
So that's where it was taking whatever we were putting into that function call to render and passing that into the template.
And this is a custom tag, let's say, where in fact this is like you see it as a method will render plenty of things. We could do something like this, of course.
So it's just making a simple change to the template, and now when we refresh, we'll see that it's again automatically recompiled this template. This is a server-side template. It's automatically recompiled it, and now it's functioning just like we'd expect there with rendering the message.
The template is pretty useless, but
we can also mix and match the Scala code. The Scala statements have @ signs in front of them, but we could also put just plain old HTML in here as well. So you want to throw in, let's just make that bold or something like that.
Yeah.
So we're just going to do plain old HTML, and when Play compiles the Scala template, it knows what is the Scala and what is the HTML to create the page. Let's take a quick look back at the main template there. Yeah. So we're calling this main method and passing it a string. You'll see that the second parameter on this main template is a content of type HTML. You'll see that the title property gets used as the title on the page. So down there. So that's the title on the page. And then the second parameter, the content parameter, gets placed into the body of this page. And so take a look back at index.scala. So the second parameter, that HTML content, is that essentially function block. The thing that looks like a function block here is being passed in as that second parameter to that main template.
And this is the title that is expecting. Something that, shall we talk about the asset?
Sure.
No, we'll say that later on.
Let's point that out. So the main, go ahead.
Sorry. The main thing is here what we tell Play is that we want you to include these different files, and these files are from the asset directory. And we'll also make sure that some files are compiled, like the less file, etc., are compiled on the spot and are included. By default, the asset directory is a public folder that you can see.
So you can even show the routes real quick. Where
let's see. Because the route is really an important file. So here, basically, we'll generate this. If you generate this URL, it will go to the public folder and will take the file associated with it.
So it's using the public path to determine where to get these static assets out of. So you can see in our directory structure that there's a public directory. Go to So there's a public directory there that contains these static assets. So one of them in the JavaScript directory is the jQuery, the minified jQuery.js. And so Play has a forward routing table based on the conf routes file, but then also sets up a reverse routing file so that it knows how to give us the URL back to a particular object or particular controller.
Okay, let's continue. So I think we pretty much see everything. So something we didn't really mention because we're so used to is Play comes with everything you need. So you don't need to download half of the internet. Everything is there already. So you have your server. You can already start developing. You saw it. I just did Play new. I have access to jQuery. You define some route file, etc., etc. Now I think it's time to actually talk about GitHub, if I remember correctly.
Yeah.
So let's switch back to the slide.
So those are kind of the real basics of Play 2. Before we go on to the next part, talking about the cloud part of this, any questions about the basics? We're going to get into models and validation and forms and all that kind of stuff in a little bit, but I want to stop and make sure
We
any
took
questions?
a bit of time. That's really a simple example, but it's just illustrate really simply how play works.
Okay.
Do you think that you can redo the hello world we just did? No? Too complicated? Too complex? Sorry. Okay.
Okay. So this talk was about developing and deploying Play applications in the cloud. So we wanted to take a little bit of time to talk about the cloud aspect of this as well. So we're going to start out talking about GitHub. How many people here have used GitHub before? Awesome.
Yeah.
Okay, great. So this will be, I'll breeze through this part, but I did want to talk a little bit about how GitHub works and why it's great for doing Play application development and collaboration. So first of all, GitHub is made in the USA. We're very proud of this.
I was forced to put that in the slide. You don't like my made in France.
So GitHub, you know, the big thing that GitHub does is it creates a way for you to collaborate around Git repositories. So Git, source control management system, it's distributed, meaning that there's no single like central server for a Git repository. If I'm developing, I have a copy of the repository, GitHub has a copy of the repository, Heroku has a copy of the Git repository, and then any other developer that I'm collaborating with also has a copy of the repository. And so this is really a central part of how Git works, is decentralizing this version control system.
So you understand why it works in the US and not in France. In France, everything is centralized. In the US, everything decentralized.
Yeah.
That's why it was invented in the US.
Sorry. Okay. So we've got these decentralized repositories. So this really helps with how we collaborate. In Git, I can do a lot more offline. I don't always have to go to this central server and say, you know, give me a change number. And there is not a concept of doing that in Git. Everything is done locally with these atomic IDs for every commit, so that I'm not having to go to a central server to get these commit numbers, to get these change numbers. So that's great. So let's actually take a look at using a Git repository with this project that we just created. So I'm going to switch over here to command line. There's, of course, IDE tools that we can use to help us with our Git stuff. I prefer the command line tools, but totally up to you how you want to do that. Okay, so in this project that we just created, I'm going to create a new Git repository. So I just say git init. And so now this creates a new Git repository. Right now there's really not anything in this Git repository, so I need to actually get my files into the Git repository. There's two steps to do that. The first is that I need to tell Git which files I want to kind of stage, which files I want to get ready to move into the Git repository. If I do a git status, we'll see that I get my files and it's saying Git's saying I'm not tracking any of these files that are in this directory. So what I want to do is just do a git add, and I'm going to just add everything. I probably shouldn't add my project files, but that's okay. We'll add them. Okay, so now they're staged. If I do a git status again, what we'll see here is now it says here's some changes that are to be committed into this Git repository. So now I can commit them. I can say git commit -m and then give it a message. So I'm going to say, all right, commit them. The commit message is init. I can see things like git log. I can see my commits. So that we're logged in as Nicholas. So we see my log message there. I just committed on your behalf. You'll see that there's the ID for this commit is this big long atomic number. So this is really important in terms of how Git works, is that you can be doing commits on your local machine, I can be doing them on my machine, and when we go to merge, all these commits are going to be atomically different, right? They're going to have different numbers. And so this is how we can really get away from this centralized system of coordinating this and really work together. So we've got our Git repository all ready to go. Now, let's say that I want to collaborate with someone else on this project. So I actually want to take this Git repository and I want to have a copy of it up on GitHub. And GitHub is really just a way to collaborate between Git users, people using different Git repositories. So to do that, let's go in the browser, and I'm going to go to github.com. And of course, we already have an account on this, so we're in as Pepite. Okay, so let's go now and create a new repository down here. So I'm going to create a new repository. We'll see you've got some private repositories up there. You have to pay for those, but that's how GitHub makes money. So so that's good. Okay, so let's go create a new repository, and we'll call this one CFP. And I'm going to make it public. Is that okay? This code's public?
It's okay.
Okay. All right. Good. Okay. So now the repository has been created on GitHub, and now GitHub gives me some instructions for how I then take my repository that I have on my laptop and then push a copy of that repository up to GitHub. So really the only thing that I need to do, I've already done the first few steps here, is take these 2 lines. So the first line that I'm copying is I'm going to add a remote to Git's configuration. Git has this concept of remote repositories. So this allows me to push and pull from a remote location. So I can have as many of these repositories anywhere that I want. They don't have to be on GitHub. They can be anywhere. But now when I add this as a remote, I can push a copy of my repository to that remote. I can pull a copy down to my local computer. So let's go run those 2 lines here. And paste. Okay, so we've added the remote, and now we're going to push a copy up to the origin. The origin is the name that GitHub uses as being like the GitHub remote. I'm not sure why they call it origin instead of like GitHub or something like that, but that's what they call it, is origin usually. You can change the name to be whatever you want. And then we're saying push the master branch. So the master branch is the default branch that I'm on. So when I created this Git repository, it set up this master branch in the repository that's just my default branch. Okay, now if I go back to GitHub and just hit reload, what we'll see now is a copy of my project here up on GitHub. So that's great. So now I've got a copy of my repository up there. I can continue to do local development, but what this enables me to do is now collaborate with someone else. So let me see, let's try this out. I'm going to try to come over and do a pull request, do a fork on my machine. So show where you would do a fork on this project. Or go to scroll up just a little bit.
Oh, yeah.
So if you wanted to take a copy of this repository and bring it into an environment that you could then work on it, you would do what's called a fork of this repository. So that's what I'm going to go do on my laptop over here. I'm going to go to github.com/pepite/CFP. And now I'm seeing this repository, but I can't make changes to Nikolai's repository. He hasn't given me permissions. He could add me and give me permissions to make changes if he wanted to, but I don't need that to happen. I can just go do a fork of this repository.
I do not trust him.
And you shouldn't. You shouldn't. So I'm doing a fork of this repository, and now I will have a copy of this repository that I own. And so then I can go in and make a change to a file here. So let me go make a quick little change to the README file here. I'm going to just come in and make an edit here. Let's say, okay, and then I'm going to save. Sorry you can't see this, but I'm just making simple changes to the README file. I've made my changes in my repository, but now I want Nikolai to take these changes. I'm saying, hey Nikolai, can you accept my changes into your repository? So what I do is what's called a pull request. And pull request is like the brilliance of GitHub. This fact that anyone can take a fork of a repository and make changes and then ask the source repository to pull their changes into the kind of main branch here. So let me do a quick pull request. So all I do is click pull request in GitHub, and then I say a little message and send pull request. So okay, I've sent a pull request. So just refresh that page. Go to the pull request page. So now you actually see the pull request. It's now an open pull request. And so you can go into that pull request and see the actual changes that I made. So those are the changes that I just made. There's the commit. Sorry, if you go into commits up here, or sorry, diff. diff. You can have multiple commits as part of a pull request, but you can see the diff of everything that's different between his version and my version. And now he can comment and say, hey, you know, that's not really appropriate for my project. Or he could say, that looks great. Let me merge this pull request. So he'll give a nice little message there, and then merge the comment. There you go, merge.
Yeah.
There you go.
Confirm.
And confirm the merge.
And after I will.
So great. So now my changes are in his version of the repository. So this is how we collaborate through Git and GitHub. It's really fabulous for collaboration. Quick little story. I worked at Adobe before I worked at Heroku, and Adobe uses some arcane like source management tool. I was an expert in Flex, but I never actually contributed any code in 6 years at Adobe. I never contributed any code to Flex because there wasn't a good way to do that. Heroku uses GitHub for all of the source code that Heroku has. So we have a lot of private repositories and also a lot of public repositories. But because everything is on GitHub, I've already contributed a number of things just in the few months I've been at Heroku to the Heroku code base because I just go and fork their projects and then send them pull requests. And of course they're like, why is an evangelist sending us pull requests, right? You know, no one trusts evangelist code. But so they do look at my code, they review it, and then they've actually accepted some of my pull requests. So this has really increased the ability for anyone to collaborate on open source or potentially closed source projects. So I'm a huge fan of GitHub.
This is the last talk of James because starting next week he will be a full-time developer
That's right.
on Heroku.
Yeah. Okay.
Let's continue.
So I wanted to give that quick introduction to GitHub just so that you can all see what it's like to do development with Git and GitHub for collaboration. But the next part of this is to talk then about, all right, we've done some collaboration in the cloud with GitHub. So how do we actually now take this application, this call for papers application that we've just built the initial version of, and how do we deploy it on the cloud, actually run it on the cloud? And so this is where Heroku comes in. So let me see real quick any slides.
This is just version 0.1, so of course the application doesn't do much, but we still
we'll
want
update
to...
it. We'll get to something more interesting in just a little bit. Okay, so deploy this on Heroku. What I need to do is create a quick little file. So Heroku has this model where we don't provide an app server for you. You have to bring your own application server with you. You can run anything, but we're not going to tell you that you have to use Tomcat or any specific version of Tomcat or any of that.
Maybe before we start, who knows Heroku?
Yeah, cool.
Okay.
Okay, good.
Heroku is basically, I'll explain it better than me.
Okay.
But you can host your application by release with simple way to host your application.
So we run your applications on the cloud, is what Heroku does. You give us your application. The typical way that we do that is through source code, but you can also upload binary assets instead of source code. And then we run it, and then you can scale it, and we'll see all that in just a second. Okay, so let's get started. So because you bring your own application server to Heroku and you can run anything that you want, you have to tell Heroku how to run your application. So there's one file that we need to create. Other than this, there's nothing Heroku specific about this. Totally portable to anywhere. So let's go create a new file. File. And this will be called a proc file. It has to be capital P, but proc file. And what this does is it maps a process name to an actual command that Heroku will call on the system to start up this process. So the process to start play, first the process name is web for this one. And then the process we're going to call is target/start. So you may be wondering, all right, this is a play application. Where does target/start come from? Well, when Heroku receives this application, it's going to run the SBT build on this project. And the SBT build is going to create a script to start up play called target/start. So that's just a simple shell script that sets up the class path and then starts up the play server. We do need to tell this process what HTTP port to use. So let me look at my notes. So here's how we do that. We specify a new config parameter, which is -d -e, and then http.port. So Heroku is actually going to tell me what HTTP port to listen on to, and then the load balancer will be able to know where to forward the request to. But I'm going to set that equal to an environment variable called port. Okay? So that's it. So now my application is ready to be uploaded up to Heroku. So to do that, Heroku uses Git as the actual way to upload files to Heroku. So instead of using like SCP or FTP, we decided that, hey, a lot of people are starting to use Git. Why don't we just use Git as the way that we upload and potentially download files? So what I'm going to do is first I need to take this change that I just made. So if we do a git status, we'll see that I haven't added my proc file into the Git repository. I need to do that. So we'll do git add and then the proc file.
And then you will send me a pull request.
And then we'll commit the change. I'll give it a nice little message here. Say added proc file.
Yeah.
Your French keyboard is a little crazy.
It's a Dutch keyboard, actually.
Okay, so now we've got this Git repository. It's got all our files in it. It's got the proc file. So now I need to tell Heroku, all right, Heroku, create a new application for me. Provision a new application for me on the cloud. So this is where that Heroku command line comes in. This is something that you install. It's on the USB keys. You can just go to toolbelt.heroku.com to get the installer as well. But this is the command line client. We're also working on Eclipse and that kind of stuff. But for now, the command line client's the primary way that we do this. So I'm going to say, create a new application for me and use the Cedar stack. Cedar is the third generation of Heroku. It supports Java, Scala, Clojure, Play, of course, all that kind of stuff.
Phantom.
So when I run this, Heroku now gives me a domain name to access my application over HTTP. So I got vividriver9059.herokuapp.com. And then I also got a Git endpoint. So you see that here's the Git URL. So this is like the Git URL that I had for the GitHub remote, but it's one that's for talking to the Heroku remote repository. So you'll see down at the bottom here it says that the Git remote was added. The Git remote named Heroku was added. I can see my Git remotes with Git remote minus V. And now I can see my two different remotes here. So I've got really two different remotes, one named Heroku and one named Origin. The Origin is for GitHub, the Heroku one is for Heroku. Okay, so now my application, my Play application, it's ready to be uploaded and run on the cloud. So all I have to do is say git push Heroku, that's the name of the remote, and then master, just like before I pushed the master branch to Origin to push to GitHub, now I'm pushing the master branch to Heroku. So when I do this, it's going to upload my code, in this case, to Heroku. The reason why I'm doing code instead of binary artifacts is that upload was only 39K of data to upload this Git repository. So that happened much faster than pushing a bunch of binary assets. But of course, Play has some dependencies, and so when Heroku runs the SBT build on this project, it will pull down all of the dependencies that Play needs to run this application. So SBT will take a minute to resolve all of those dependencies through Ivy and download them. But then it'll create what Heroku calls a slug file that has my application and all the dependencies in it. And it will then launch that application on what we call a dyno. A dyno is just the place that slug files run, the place that these applications run. By default, we get one web dyno that will process a request from our application, HTTP requests. But I'll show you scaling in just a minute. So it'll take a minute to resolve the dependencies.
The best part with Heroku is you can actually use it on, I think you have one dyno for free per month, huh?
Good thing to point out. Yeah, so as a developer, you can get started with Heroku for free. Every application that you create, so every time you do a Heroku create, that application gets one dyno for free every month. So 750 free dyno hours. We build by dyno hours, 5 cents per dyno hour. But you get one dyno for free. 750 hours is enough to cover a month. And so you get one dyno for free every month for every application that you create.
And it's really nice to use, and you get really quickly addicted to it.
Yeah.
We have a scoop, by the way. The badge were done actually using Play2 by Nicola, and it's deployed on Heroku.
Yeah. So if you the little QR codes on your badges, on what? Everything.
The
whole, okay, not just the QR code. The whole badge is created on the cloud with Heroku. Is that right? And it's a Play 2 app? Yeah. With Java or Scala? With Java.
With Java.
Awesome. Okay. So they're probably running on just one web dyno. Maybe they scaled up because, no, just one web dyno. So they haven't had to pay anything. That's great. For free.
Because they don't have any money in Devox France.
So the first time we do this build, the first time we do the git push, it's going to take a little bit of time because it has to resolve all the dependencies. Future pushes won't take as long because it's not going to have to re-resolve all these dependencies. So this first one takes a little bit. The next one that we'll do later on should go quite a bit faster. But once this gets done building SBT is not the fastest build tool on the planet. Something that the TypeSafe folks are working on for future versions. But once this is up and running, we'll see it in the cloud. But while we're waiting for that to happen, let's go back here. So just to give you a little recap on this, create the proc file, then we just do the Heroku create and git push, and that's it. Okay, so play Heroku and GitHub. What is that? It's the French.
Yeah, ménage à trois. Hein?
Ménage à trois. So
really the common link to all this is Heroku, GitHub and Play is simplicity. It's what we try to show is really like having something useful and simple to use.
Yeah.
After, it's really great because you start your application in no time. You can collaborate with your team members and improve your application, and then you can deploy within no time. You don't really need anymore to plan in advance. Oh, I want to go on production. Let's have a meeting. And when can I go on production next week? Well, next week? Are you crazy or what? I have some other things to do, you know? I don't want to deploy your crappy application on production. No, you can deploy your application on production whenever you want.
Yep. Yeah, so the concept of continuous delivery, being able to send Heroku updates, have it do a rebuild, redeploy, and do that in just like a minute is really powerful. Also, this works really well with how Play handles database evolutions, so that we can do our database evolutions. The recommended approach to how we do this in a continuous delivery environment is kind of like a three-phase schema migration. So what we do is we'll do one continuous delivery release that's just updating the schema, and that's very easy to do with Play 2's database evolutions. We'll show you more of that in just a little bit, and then do a second release that actually would like update the controllers and the UI to use the new schema. And then the third step would be if you need to do any cleanup from this two-phase process, then you could do that in a third step. So I heard this great talk by Netflix. They do a lot of continuous delivery, and they say, all right, if you need to make a schema change, you need to do that 1 week ahead of the actual release that then uses that new schema. So they decouple those two things, which really allows them to better manage, because we always run into problems where when we try to do both of these things at the same time, there's something that doesn't go right, some kind of database, things didn't change in the way that we expected them to. So continuous delivery plus this like 2 or 3 phase way of doing schema migrations is really the recommended way to do this. Play 2's database evolutions makes this really easy. You don't have to do it that way. Just a recommendation on how you implement continuous delivery with schema migrations. Okay.
However, it's easier to do it. That's why.
Yeah. Here, see if the SBT build finished. Okay, so let's go to our browser now and see if our app is up and running here on the cloud. So, we forgot to give it. It is running. We need to give it a parameter here. So give it our parameter, and there we go. So this is now live.
This is live. I think we can have a break. We did a good job.
Yeah, we did. So anybody could go to vividriver9059.herokuapp.com.
Of course, in Heroku, you can also assign a specific domain name, DNS name, etc.
Okay. We're at break time, right?
Yeah, I think it's break time. Yeah, I wasn't joking.
Cool. Great. So right, we're going to take a 10-minute break, and then come back and we're going to add models, validation.
We'll do something a bit more complex.
We'll do some real time at the end with Comet. Okay, cool.